Today's webinar is entitled Data Collection and Analysis with Charlie Zegeer, Director with the PBIC. Before we get started with today's program, I want to give everyone a little information about this webinar series. The goal of the Pedestrian Safety Action Plan webinar series is intended to help communities address pedestrian safety issues and initiate the steps to drafting a tailored pedestrian safety action plan. Modeled after the Federal Highway Administration and PBIC's in-person training course, How to Develop a Pedestrian Safety Action Plan, this free webinar series will cover topics ranging from funding to safety enforcement. The next webinar in the Pedestrian Safety Action Plan series is scheduled for Wednesday, June 1st, 2011 at 2 p.m. Eastern Time. This webinar is entitled Pedestrian Safety Education and will be presented by Nancy Pullen-Sufert, Associate Director with the National Center for Safe Routes to School. Please visit www.walkinginfo.org/webinars to register for this webinar and future ones in the Pedestrian Safety Action Plan series. The 7-part series was developed by the Pedestrian and Bicycle Information Center, a national clearinghouse of pedestrian and bicycle-related safety information and resources. We offer information and technical assistance to diverse audiences about health and safety, engineering, advocacy, education, enforcement, access, and mobility as it relates to pedestrians and bicyclists. The PBIC and today's webinar are both made possible with funding from the U.S. Department of Transportation Federal Highway Administration. Today's session will be archived and available for download on our website at www.walkinginfo.org/webinars. In addition to these webinars, PBIC offers 4 different in-person training courses to provide technical assistance to professionals and community members in developing pedestrian safety action plans and improving conditions for walking. These courses can be found at walkinginfo.org/training. Now I'm going to turn the screen over to Charlie for the feature presentation, Data Collection and Analysis. I'd like to welcome and thank Charlie for his presentation today. We will take questions at the end. Charlie, please take it from here.
Okay. Thank you. Basically, what I'd like to do today is talk about what kinds of data that should be collected and analyzed to help in an overall pedestrian safety action plan with the goal of reducing pedestrian motor vehicle deaths and injuries. So essentially we're going to break this presentation into the data collection part, to ask the question, what data should be collected to address pedestrian safety problems. And then the second part will deal with how do you analyze the data, what kind of analysis techniques are available to help us determine the specific problems, and then that leads us to appropriate countermeasures. So I will say that this presentation, as Davian said, is the 3rd presentation of a 7-part series based on this guide that you see called How to Develop a Pedestrian Safety Action Plan, and it is also a workshop, a 2-day workshop that our team has been providing with funding from the Federal Highway Administration, primarily to 14 focus states and 5 focus cities around the U.S. Okay, so getting into the issues of data collection and analysis, we always try to talk about learning objectives. The purpose of the module that I'll be presenting today is to basically describe, what and how meaningful and useful data needs to be identified, collected, and incorporated into your pedestrian safety action plan, and some of the details there. We will be talking about some of the goals of data collection. Why do we collect the data? What do we want to use the results for? Some of the types of safety projects that lend themselves to making use of this data, and then beyond crash reports. Essentially, what we will be talking about is sort of one of the modules in the middle of this overall pedestrian safety action plan. The first module that you heard in this series was talking about planning and design issues. And then one of our speakers talked about involving stakeholders. Who are the different types of folks within a city or state DOT that need to be involved to help with the overall pedestrian crash reduction process? Then my module will talk about data collection analysis, and then the next series of modules will deal with making use of the results of this data to select engineering, education, and enforcement strategies or countermeasures. Then we have a module on obtaining funding. Where might the funding come from in order to pay for implementing some of these countermeasures, particularly engineering, but also other education and enforcement measures. And then the fact that we need to implement and evaluate the different countermeasures. And all of this is part of an agency's overall pedestrian safety action plan. So anyway, as part of that, and dealing with collecting data, we need to understand that to really boil all this down into some manageable units of analysis, we like to talk about crash data and looking at pedestrian crashes, where they occur and some of the characteristics, and then locations with a high crash potential. These two goals make up what agencies are supposed to have as part of their overall safety goals, to identify crash problems and then locations and issues that potentially could lead to crashes if we don't do something about it ahead of time. So we are going to be talking about high crash locations, corridors, and areas or neighborhoods. These are sort of the three units of analysis that we deal with, not only in collecting and analyzing data, but also in selecting countermeasures. For example, for intersections or spots and corridors, we often talk about different kinds of engineering treatments that can be implemented. We talk about areas or neighborhoods. Oftentimes, we may be talking about educational types of programs or even enforcement. But certainly all three of these types of measures are essential ingredients in having an overall successful pedestrian safety program. All right, some general data collection guidelines that we've come up with are, first of all, we want to encourage everyone to make sure that you conduct your site visits, your field visits, to observe what's going on in terms of behaviors by the pedestrians and motorists, bicyclists, other road users, so you can really get a better handle on why things are happening, why are crashes happening, or why are you getting complaints from citizens about safety problems here. Then only collect what you need. We need to use our limited resources wisely and efficiently, for collecting and analyzing data. And so we only want to collect what we can use. Generally, when you talk about looking at pedestrian crash analysis, you want to collect between about 3 and 5 years of previous pedestrian crash data. If you go much further back than that, sometimes conditions have changed, say from 8 or 10 years ago. So that may not be as useful as sort of your more recent 3 to 5 years of pedestrian crashes. Also, using the crash data certainly is important to help you identify where crash clusters are occurring, whether it's spots or corridors or areas. But then when you get into looking more specifically at some of the high crash locations, that's when it's important to get your hands on copies of the police crash reports themselves. Because reading those police crash reports can also give you helpful information on what's been going on, what kind of situations were occurring, and that can really help you understand the problem and select the appropriate treatment. And we also add at the end of this slide, we say don't jump to conclusions too soon. Sometimes we may see a few crashes and say, oh, I know what the problem is, but really be patient, go and observe the site, look at the other information, the traffic volume and speed data, other characteristics of the sites, look at the geometrics, and then you can have a better chance of understanding the problem and selecting the proper countermeasure. Other data collection guidelines is we don't want to miss out on our most recent few months of pedestrian crash data. So if you can get data that's fairly current, you're better off. It's also useful to go back, as I said, at least 3 to 5 years, make use of information from citizen complaints, from police officers, from input you get from other people within your departments. And particularly crash data for the last 3 to 5 years are essential in better understanding what's going on with respect to new businesses in the area, new activities by pedestrians and motorists, the current user groups. Is it near a school? Is it near a senior center? Different travel behaviors by motorists as well as pedestrians. So you want to be able to capture the last few years. In terms of the types of projects, we are going to talk for a minute about what kinds of data to collect at our intersections or spots or corridors, our neighborhoods, but also within the entire jurisdiction, because there are some kinds of problems that may be common within an urban area. Like if you're in a city within Florida, for example, you may have a high percentage of your population that's senior pedestrians and senior motorists, and that may result in certain kinds of behaviors that may be addressed through education or through some other kinds of engineering or enforcement measures. For example, when we were involved with analyzing data in Miami-Dade County for a study for the National Highway Traffic Safety Administration called the Miami-Dade Pedestrian Safety Demonstration Project, we identified 3 areas or zones within the county, each of which had very different characteristics and behaviors. One of the zones was Little Haiti in Liberty City, and that had a lot of younger children, minority children, being struck by motor vehicles on the way to and from school. So that really resulted in some educational measures, working with the school systems. And we had another area called Little Havana, and they had a lot of senior pedestrians, Hispanic pedestrians, that were getting struck by motor vehicles crossing arterial streets throughout the day. And so that led to some recommended engineering treatments to try to do things like add raised median islands and to try to educate some of the pedestrians in senior centers and other kinds of public service announcements, and as well as some enforcement. Our third area was in South Beach area that resulted in quite a high percentage of younger adults being struck by motor vehicles, particularly at night. Many of these involved alcohol, and that led to a series of recommendations for a wide variety of countermeasures, things to slow down vehicle speeds, to improve signal timing, to implement some enforcement of motorist behavior, some education, and a variety of treatments there. So collecting the data in these kinds of areas help lead to better selections of countermeasures. Now, some of the types of projects we can talk about: spot locations. When we go out and start looking at sites that either have several pedestrian crashes at intersections like this, or maybe a series of complaints from citizens or others that there are speeding or lack of yielding or unsafe behaviors, we might want to be looking at things like sight distance or the width of the crossing. How many lanes does a pedestrian have to cross from curb to curb? Is there any raised median? What are the speeds there? Can we get speed studies? Are speeds too high? Could things be done to lower speeds, either through engineering or enforcement? What about the behavior of some of the users? Is it near schools? Are there children or seniors or other kinds of groups that you may want to address either through education or through some other kind of treatment? When you talk about corridors, you can see here that there's really no obvious location to add a pedestrian crossing. So pedestrians, you can see the one sort of near the top of your screen that's standing in the center of this 7-lane roadway, and oftentimes there may not be, it may take quite a bit of analysis to figure out, well, what is really needed here. There may not be one location along here that may warrant a traffic signal or even having another designed pedestrian crossing. But are there other things that could be considered, like having raised median islands or some other kinds of devices to slow down vehicle speeds, maybe reducing the number of lanes through what we call a road diet improvement. Maybe you don't need 7 lanes here. So next time you resurface the road, maybe it can be striped for 5 lanes, possibly with a raised median island for pedestrians to have a place of refuge. So we need to be thinking broadly, even during the data collection process, about the kinds of behaviors and conditions there that might lead to some reasonable countermeasures for pedestrians. And then there are corridors where there may be common solutions. For example, if you have a series of bus stop locations along a corridor like this, maybe there's a series of treatments that might allow pedestrians to more easily cross the street to get to and from the bus stop. So this is basically a marked crosswalk in a staggered pattern, so the pedestrians would cross when they get a gap in traffic, or when motorists would stop and yield, to the median. Then they would make a right turn so they could see oncoming traffic coming from the right, and wait till there's a gap in traffic or for traffic to yield to them, and then finish crossing. And so this is one example of a kind of treatment that might be sort of systematic along a corridor to help pedestrians cross at key locations. There may be areas within an urban area, for example, like this, where pedestrians are running across the street for one reason or another, where there are long distances between signalized crossings, where it's important to really go out and collect just some basic information to understand what's happening. You know, what are the pedestrian origins and destinations? Where are they crossing? Are there things that could be done to make these crossings safer? And what kind of data do we need to collect to help us come to those conclusions? There may also be system-wide issues. Like this is one intersection in a southeastern city. That's me crossing in the marked crosswalk. You can, if you look up at the signals or across the street, you can see that there are traffic signal heads, but no pedestrian signals, no walk, don't walk signals. So a pedestrian may not be able to even see the indication that the motorists see, and a pedestrian may be sort of guessing when it's safe or appropriate to cross the street. So if you have senior citizens or children in particular, that may cause a certain risk for pedestrians, particularly during higher volume conditions or in rush hour. So looking at intersections like this throughout an urban area where you may have multiple signalized intersections without pedestrian signals. Are there some policies or some priorities that can be placed on installing pedestrian signals, you know, where they're needed? And the question is, all right, why is this important? That we say here that you don't necessarily need to collect pedestrian crash data and exposure data for your entire system before you can start doing anything. Now, certainly we want to have system-wide pedestrian crash data. This is often available through our Department of Motor Vehicles on a statewide basis. Some cities may also collect their own database of crashes, and certainly you want to have that complete database. Unfortunately, though, in terms of exposure data, many cities don't collect much exposure data. We encourage them to do so. Pedestrian exposure can be very useful in conducting a citywide or area-wide analysis of pedestrian safety. But what we're saying is you shouldn't necessarily wait for all the exposure data to be available before you start with your pedestrian safety program. It can be useful in computing pedestrian crash rates and things like that, and determining where there are demands for pedestrians, where you can meet certain warrants, like for traffic signals and pedestrian signals, and where there's a need for crosswalks and other crossing amenities. The other item here says that if a pedestrian safety problem has been identified, that you can, decide what kinds of data is most needed for that site, so you can begin selecting the appropriate countermeasure and implementing those countermeasures as soon as possible. Okay, so how do we consider or define the extent of the problem? This is a plot of pedestrian crashes. You can see the blue dots along the two corridors here. The red lines here are the urban arterials. And the urban arterial on the right side of the screen, you can see a number of blue dots or pedestrian crashes. And so by looking at an overall visual picture of where the pedestrian crashes are occurring, that can really help you hone in very quickly on where you need to go out and further analyze stretches of highway corridors in this case, and determine what problems are occurring and what countermeasures may be appropriate. Now, when you look at a broader area, this is actually Miami-Dade County. These plots were developed through the Miami-Dade Pedestrian Bike Coordinator, David Henderson, and he was really the champion of this project. We worked with him and a project team for this project for the National Highway Traffic Safety Administration to identify where there are clusters of pedestrian crashes, where are the neighborhoods and areas where crashes are occurring, as well as spots and corridors. And then we selected a total of about 16 different types of pedestrian treatments, many of them education and enforcement, as well as some engineering treatments. But in order to identify, what are these appropriate treatments, we had to not only look at where the crashes happen, as you can see on the left side of the screen. Each red dot represents a pedestrian crash that occurred in the county between 1996 and 2000. The plot on the right, you can see where ArcView software was used to identify 3 zones. I talked about these earlier, so that you could see where the areas were with high concentrations of pedestrian crashes. And then these zones led to further analyzing the crash types and characteristics, and that led to a number of engineering, education, enforcement treatments. All right, now here's sort of a blow-up or a close-up of one of the corridors in the Little Havana area. And you can see using the ArcView software that this allows you to really see where the clusters of crashes are occurring, not only along the corridor, but at key intersections. You can see the dark blue and dark green areas represent where there was a concentration of pedestrian crashes. And then what we did is we went out into the field, we looked at these sites, walked through them as pedestrians, we drove through them as drivers, and we could get a better sense of what's going on. Also observe pedestrians and motorists for quite some time, and to see what may be causing some of the crash experience. Collecting the data to analyze pedestrian crash problems involves several kinds of things. We talked about computerized police data, and we recommend that be geocoded so that the analysts can develop computerized crash maps and quickly be able to target the locations that need further analysis. But in addition, it's important to have some kind of information on the conditions of the roadway, number of lanes, types of traffic control, things like that, as well as the location of sidewalks and walkways. Knowing the traffic characteristics, traffic volume, the characteristics of turning movements, and percentage of vehicles by type. Pedestrian counts and behavior information is useful, and this should be done at the sites where you go for further inspection. It's important to understand the pedestrian guidelines and policies that your agency has. And are some of these policies contributing to maybe some of the pedestrian crashes? Are your walk signals timed properly to allow enough walk time for pedestrians? You have well-trained adult crossing guards at your elementary schools where appropriate. Do you have adequate network of sidewalks and walkways for your pedestrians? And certainly making a site visit can help you to understand the answer to some of these questions. Now, getting into a little bit more detail on the collision data is it's important that we do have a full picture of the pedestrian crashes, when they're occurring. We need to get copies of the police report, to read the narrative when we're looking at a location, to review what the officer said about each of the pedestrian crashes. And again, geocoding the crashes is a good first step in targeting where the crash locations are. When we were further analyzing the pedestrian crash problems in Miami-Dade County, we actually had copies of the police reports sorted by intersection along a corridor. So as we would walk along a corridor, we would stop at an intersection, we would pull out the crash reports for that intersection and review them right there in the field. And then by looking at the intersection, watching the behavior as we reviewed the crash reports, we could really start to understand why certain kinds of crashes may be occurring. Was there a high left turning movement combined with heavy pedestrian crossing across a certain leg? Were there certain behaviors by pedestrians like walking against the light, or motorist behaviors like speeding or failing to yield that might be contributing to crashes? There was a couple sites where we even noticed that there were, from the police reports, that the crashes were occurring in a grocery store parking lot because it was actually drawn on the police report sketch. So we actually went into the parking lot and watched the flow patterns of the motorists and the pedestrians coming into and out of the store, and it was really obvious they had a very bad flow pattern with poor sight distance, and that was clearly contributing to some of the pedestrian crashes. We had other places like near bus stops or at gas stations where there were pedestrians being struck by motor vehicles. So it's really important to have the details from the police crash reports with you as you review the sites to understand what's going on. And you can see here, here's an example of, looking at this sketch, you can see the right turn motorist that struck the pedestrian that was stepping off the curb. So, what's going on out there? Looking at the sight, was there a poor sight distance, or was a motorist looking to the left and not observing pedestrians crossing in front of them? Or are there other sight conditions that might be contributing to this kind of crash? Now, in addition to having the crash data, it's important to understand, where there are missing sidewalk links. Do we have maps or information on traffic flow, the average daily traffic, the street widths? Because we know that wide streets and heavy traffic and high speeds, those combinations of conditions can really present high risks for pedestrians trying to cross. So also having some idea of pedestrian counts, the ages and characteristics of the pedestrians, how many are crossing, where they're crossing, can also be an important ingredient in your analysis. And looking at locations like this, where you may have missing sidewalks, and it's pretty clear that if you have crashes occurring during a certain time of day, it's important to go out there during that same time and day of week, if possible, or it's a weekday problem or a weekend crash problem or a nighttime crash problem, and go out and look at what's going on during those days or times of day, and that can really help give clues as to what is causing some of those crashes. Okay, now here's an example of a street, and if you're going out to look at a site maybe that's had a lot of complaints or pedestrian crashes or both, it's important to look for things that may be going on that you can just observe from your vehicle or from standing in the street. Just to give you some examples of things we observed in one of our citywide studies, we had several pedestrian crashes that occurred really on a two-lane, fairly low-speed street that divided a pedestrian mall. And so it wasn't really clear to us from the police reports why these crashes were happening. When we went out into the field, we noticed that every cycle, the walk and don't walk signals would come on at the same time. Now, the engineers told us when we got back to the office that was impossible, but yet we took photographs and showed him that that was indeed happening. We had other locations with motorists striking pedestrians on the sidewalk. And we went into the field and noticed that the bushes between the sidewalk and the properties had grown up so tall that motorists exiting the driveways couldn't see a pedestrian until they actually had the front end of their vehicles across the sidewalk. So this was an obvious thing, trim the bushes. We had another city where we had a lot of pedestrian crashes happening at certain intersections along a major route. So happened that these were primarily where the buses were stopping, and we would observe pedestrians running diagonally across the street to the bus or getting off the bus, stepping out from in front of the bus into the path of oncoming traffic. So it's really a matter of issues concerning behaviors at bus stops and what are some of the things that could be done to change behaviors or implement engineering treatments there. Another intersection we saw nearby there, pedestrians were walking between stopped cars that were backed up from a traffic signal on the red light. And this was causing a problem with oncoming traffic not seeing pedestrians until they stepped right out in front of them from in front of SUVs and minivans, etc., which was causing a problem. There's one other intersection that we had that was controlled by a state DOT in a southern state. And there had been several pedestrian crashes at this one intersection. It was signalized. When we went out there, we noticed that there were pedestrian signals and crosswalks on 3 of the legs, but not on one of the legs. The leg that had a wide sweeping turn radius, they'd actually taken out the crosswalks, they'd taken out the pedestrian signals, and had put up a sign that says no pedestrian crossing allowed. And so, of course, what was happening is pedestrians were not crossing the 3 legs, but they were still crossing that same leg, even though it said no pedestrian crossings. One pedestrian said to me, "What are we supposed to do?" as he dodged a right-turning vehicle. And, of course, the solution there should have been really reconstructing the intersection radius of that turn so it was tighter, it shortened the crossing distance, resulting in a slower right-speed turn instead of trying to prohibit pedestrians from crossing there because pedestrians were not obeying the sign. And we saw no pedestrians that were crossing the 3 legs in place of the 1 leg. So just some very obvious things you can notice from being out in the field. You can go out at night and observe certain kinds of behaviors like you see here. You know, are speeds high? Are pedestrians crossing the street at certain locations without looking? Is this even a proper location to have a marked crosswalk alone? Or should there be some other enhancements here to assist pedestrians crossing the street? In many cases that we can really understand a better solution simply by observing. Some of the behavioral studies that we might want to conduct is just observing at a location can lead you to understanding, you know, what are the problems. There was another location in one of the northern states not too long ago. It was near a junior high school, and there have been several junior high school kids that have been hit by cars during afternoon school periods. And we noticed by observing that they had one older adult crossing guard that was being ignored by the junior high students. They would cross when the guard would tell them not to. The motorists were ignoring the guard and driving right through even though the guard was telling them to stop. And it was really chaos. And it wasn't very difficult to understand why pedestrian crashes were happening. So a number of treatments were recommended there to really try to get control over the situation. Also looking at what's going on in terms of, you know, where and how pedestrians are crossing and how are motorists behaving. When we were in Miami-Dade County and we went to some of the neighborhoods to look at behaviors on some of the high crash corridors, we were in one area called Little Haiti, and we would notice that many of the senior pedestrians would cross these wide 4-lane, 5-lane streets, and they would stand right in the middle of the roadway waiting for oncoming traffic to pass. And many of the vehicles were passing within a foot or two of them as they stood in the middle of the street, and then they would finish crossing mid-block. We noticed that in some of the areas, very different kinds of behavior. Some of the behavior by the children in Little Haiti and Liberty City were really putting them at risk in terms of running across the street or crossing in unsafe ways, motorists not yielding to pedestrians in crosswalks. So that kind of behavior is important to note to help you understand what countermeasures are appropriate. We have looked at pedestrian crash problems in many urban areas, and what's common is some pedestrians may walk against the don't walk light, and at the same intersections, motorists may not be observing the legal right-of-way that pedestrians have during the walk phase, and maybe turning left or right across the pedestrian's path. So sometimes enforcement is important, particularly to motorists, to improve their behavior to comply with the speed limit and also with laws requiring them to yield to pedestrians in legal crosswalks. Also looking at a roadway situation or corridor that may not be very pedestrian friendly, looking at the quality of the environment for pedestrians, the walkways or sidewalks. Are they being cleared of snow and debris or ice? Do we even have adequately designed sidewalks and walkways for pedestrians? And what about the pedestrian crossings? Are they built in a safe manner for pedestrians to use them? Here's an example of an intersection where they actually resurfaced it and retrofitted it from a 4-lane road one-way to a 3-lane road with a bike lane. They added a curb extension to reduce the crossing width. They added on-street parking. They widened the sidewalk. And it really did slow down speeds. It reduced the crash risk. It resulted in increased use by pedestrians and bicyclists. And it really did result in a safer street for all different road users. And one of the things that we do know from the research is that many of the improvements that benefit pedestrian safety also benefit motorist safety. For example, road diet improvements we've made mention of, where you're reducing the number of lanes from 4 or 5 lane down to 3-lane roads. That our research shows that crashes can be reduced by about 29% for total crashes. And some of the research we've done for pedestrians on marked versus unmarked crosswalks shows that having fewer number of lanes also reduces pedestrian crash risk. Just a few other examples of some of the treatments that can improve safety for all road users that can benefit pedestrians. Adding raised median islands, give pedestrians a place of refuge, can reduce pedestrian crashes by 30 to 40%, but also reduce motor vehicle crashes, particularly head-on crashes and left-turning crashes. Having paved shoulders can give pedestrians and bicyclists a place to ride or walk so they're not in the travel lane. Research shows that can reduce pedestrian crashes by 80 to 90%, but also research shows that motor vehicle runoff road crashes can be reduced by having paved shoulders. So again, some of these treatments can reduce crashes to all users. One other example is adding separate left turn phasing dramatically reduces pedestrian crashes and through vehicle crashes with left turn motorists. So something to keep in mind. Okay, getting into a summary of data collection. Again, we want to think about the spots, corridors, and neighborhoods, as well as jurisdictional issues and problems. We want to make sure to have pedestrian crash data 3 to 5 years. We want to observe pedestrian and motorist behavior in the field and collect basic roadway inventory information, as well as our traffic and volume information and our crash data. But also realizing that you don't have to collect every single piece of information that you would ever want in order to oftentimes identify what is the problem and have that lead to countermeasures. Okay, so essentially we're wrapping up this first module, and we've talked about what and how to collect meaningful data for pedestrians as part of their pedestrian safety action plan. So if you have any questions right now, you can start typing those in, and Davian will collect those, and we can answer some of them at the end of the presentation. Okay, next we're going to get into analyzing data. What are some of the different analysis techniques that we can use after we collect some of this information? And the learning objective here is to discuss how we can use this data that's being analyzed to lead to countermeasures that can be implemented at our sites. And we are going to talk about not only looking at high crash locations and a little bit about some of the countermeasures that may come from some of this analysis, but we want to also talk about the extent by which you can implement some of these treatments, and then the importance of setting priorities for implementation. We know we don't have unlimited funds. We need to make use of the resources that we have to do it in a cost-effective manner. And we are going to look at, again, spots, corridors, areas, and jurisdictional issues. One of the tools we can use to analyze pedestrian crash data is what we call PBCAT. It's Pedestrian Bicycle Crash Analysis Tool. It was developed largely by the Highway Safety Research Center here at UNC for the Federal Highway Administration, and trying to analyze crashes in terms of the type of crash. Things like mid-block dash, turn merge, where they're left-turning or right-turning motorists, walking along roadway crashes, like often occur at night, and trying to take our sample of pedestrian crashes, analyzing them by type, and then this software allows you to not only enter the basic data, but it also has links to appropriate countermeasures for each crash type. Then you can go, well, here's just an illustration of what the PBCAT software looks like. We have this information on our website. I'm going to ask Davian to link some of the resources I've been talking about to the webinar, so those of you that don't have these can find them easily. This is the PBCAT software, and it allows you to really analyze crashes on a systematic manner in selecting countermeasures. The field reviews, we talked about those some, but we need to summarize the data, whether it's conflict data or you've analyzed you want to analyze the percentage of pedestrians that walk during the walk, flashing don't walk, or steady don't walk period, in terms of reviewing data from the motorist, in terms of speed data, yielding behavior. And we want to review the site of the crashes or the complaints, not only from the standpoint of behaviors, but also characteristics of the sites, the number of lanes, the speed limit, vehicle speeds, types of traffic controls there, and things of that type. And of course, more data will be needed for sites that are more complex to analyze and have more difficulty in determining the cause. We also want to talk about the phasing of implementation, that there are some kinds of treatments that will be discussed in some later webinars that can be phased in throughout an area or neighborhood or along a corridor. We talked about reducing the number of lanes from 4-lane to 3-lane. We can talk about some geographic treatments like educational programs that can be implemented at schools or senior centers. We can talk about piggybacking projects where if you're going to have a construction project, here's an example of where an agency installed a number of curb extensions along a corridor. They were actually having a utilities improvement anyway, so they had to tear up the street, and as part of the reconstruction, they decided to install a series of curb extensions which shorten the crossing distance for the pedestrian at certain intersections, and they can also help to reduce vehicle speeds. Things that can also be done as part of a system-wide improvement are things like different engineering treatments. The city of Orlando, for example, a few years ago decided to systematically replace all of their parallel line crosswalks with high visibility crosswalks. So they decided to phase out the parallel lines and put in the more visible crosswalks. And they actually, so they thought they saved money in the long run because the higher visibility crosswalks lasted so much longer. So you can make implementation of some of these treatments on an area-wide or system-wide basis throughout your city or town. Other treatments like adding a bridge. Well, that's a great opportunity to add your sidewalk or walkway for pedestrians, because otherwise if you build a new bridge and don't put it in, then it probably is not going to be ever added to the bridge. And you want to make sure that pedestrians are provided on bridges and other facilities to reduce the chance of collisions in the future. Or sidewalks and lighting. I mean, these are two essential elements for pedestrian safety. We say that having a well-planned network or system of sidewalks and walkways is kind of the backbone of a pedestrian transportation system. If you don't have them, then your crashes go up, pedestrians walking in the roadway, motorists are having to contend with pedestrians at night, during the day, and really can cause problems to all the road users. Having lighting is certainly important in along corridors where there is nighttime activity, and it can really reduce nighttime pedestrian crashes, as well as motorist nighttime crashes. Here's an example of a curb extension that was done sort of under a low budget arrangement. You can see adding this curbing, though, really shortened the crossing distance dramatically. The pedestrians would have to go to cross the street from the left to the right side of your screen. It also now is forcing vehicles to approach the intersection at more of a 90-degree angle, which allows them to see traffic better coming from their left. So again, another example of a win-win situation in terms of improved pedestrian safety as well as improved motorist safety. Here's another example where this agency extended the sidewalk. So what happened is it really resulted in a much reduced width of your driveway opening. Again, shorten the crossing distance for that one pedestrian crossing there, and motorists are approaching at a right angle, and they can see much easier to the left before turning into the major roadway. So one of the questions is, though, all right, well, we have so many needs there. We have so many sections without adequate sidewalks. How do we manage this? You know, what are some of the methods we can use to set priorities for implementing treatments? So what I'm going to do is talk about an example from Seattle where they had sort of a daunting task of so many missing sidewalk links. And you know, how could they manage this? If they don't have all the information they would like on pedestrian exposure and other data, you know, in any kind of format to really make any kind of rigorous analysis. So what they did is they decided to take the map of their city, divide it up into bite-sized chunks, and then try to establish some overlapping priorities. And what do we mean by that? Well, you can see here they have located the urban villages in the yellow there, you know, where a lot of activity should be, from retail, commercial areas where pedestrians might be expected to go to buy goods and services. They superimpose the schools, the area around schools. You can see here in the blue circles where the elementary and middle schools were. Then they superimposed on top of that where the service providers are. Post offices, gas stations, restaurants, libraries. And where these three areas overlap, it says bingo, these are the highest areas where they would identify to add missing sidewalk links. You know, it's fairly easy to do, and so now they have set priorities for adding sidewalk links for priorities 1, 2, and 3 over the next 10 years or so. And so can they make all these improvements right away? Of course not. But what they can do is they can set some reasonable priorities for making improvements to do the most good first. Now there are other methods like this. This is from one city that established some criteria for a rating system, like the severity of the problem, the effectiveness of the solution. Is it going to be effective, high effectiveness, or low? What is the probability of use or the travel demand by pedestrians, the likelihood of funding, how feasible is it to be done in conjunction with other projects, what about public support, how much does it cost? So anyway, just setting up a kind of a simple priority rating system. And so you rate every potential project on this 100-point scale and then order the candidate projects from highest to lowest points, and then do those projects first. Another option is to use kind of a cost-effectiveness method, where if you can determine the estimated effects on crash reduction, and then can apply that to determine a crash savings in terms of dollars saved divided by the cost of the improvement, and then order the projects by benefit cost ratio. So there are different methods to do that. But whatever method you use, try to find the places that have the most crash problems or most crash potential, and where you can do the most good quickly. Sometimes it's not so quick. You can try to set up time frame for making improvements, especially if they're major improvements. But we really want to try to address as many of the problem sites as we can, either through engineering, education, or enforcement. So in summary, for the analysis part, we want to, again, identify types of locations that we should look at in more depth to collect and analyze data to ultimately reduce the most pedestrian deaths and injuries that we can. And we want to set up a schedule to implement them, whether it's as part of other planned projects, other reconstruction projects or other utilities projects, or even from routine maintenance. There's much we can do, or setting aside safety funds for making improvements, and trying to think about our system as a whole and how we can get the most bang for the buck. Now I'm going to run through just a few examples of some resources that might be appropriate to go along with some of these recommendations. This is sort of a method that we developed here at the UNC Highway Safety Research Center called the Intersection Safety Index. And what this is, you can see the cover of the guide for the pedestrian and bicycle intersection safety index. But it's a methodology. We have a research report on the left and a user guide on the right. And it allows you to rate intersections based on a 6-point scale, where a 1 or 2 rating means that it's really safe for pedestrians, a low volume, narrow street, low speed, where even children could probably cross there at a certain age without a lot of risk, up to the higher numbers, 5 or 6, that mean they're so dangerous, wide streets, high volume, high speeds of vehicles, very difficult to cross. And but you can apply this method fairly easily and quickly to literally hundreds of intersections, say in your downtown area or suburban area, without having to wait for crashes to happen. Remember earlier we talked about wanting to meet 2 goals. One is to reduce crashes where they occur. Secondly, to identify the potential for crashes and try to treat those sites before crashes start happening, if we know that there are potential high-risk problems there. So just to give you an idea very quickly of what this system does, this intersection safety index, we try to use crashes, conflicts, avoidance maneuvers, and safety ratings, where we had many experts around the country rate different intersections in terms of how safe they would be for pedestrians. We were able to use safety ratings and avoidance maneuvers by pedestrians, in particular and other behaviors to merge with site characteristics like this, things like traffic volume, number of lanes, curb radius, driveways, pedestrian signals, lighting, other issues like this, and come up with kind of a method. You can see here we would use sketches and videotape, like you can see illustrated here, that we had our team of experts around the country that would rate these intersections 1 to 6, and then based on the characteristics of those intersections, we came up with a model that identified certain factors as associated with higher risk for pedestrian crashes or for potential crashes. Things like higher number of lanes, higher vehicle speeds, higher traffic volume in conjunction with traffic signals, commercial areas. These are all factors, when they were present, were associated with higher risk of pedestrian crashes, of potential crashes, and therefore higher ratings on this 6-point scale. Now, factors like the presence of a signal alone with ped heads, or stop signs, things like that that would interrupt traffic flow were associated with lower crash risk. So basically, without going into too much detail on how we developed the method, you can either use a spreadsheet or we have kind of a quick reference table series where you go into the user guide. You enter your number of lanes. Your traffic volume here was, let's say it's 22,000. You can go over to the number of lanes, 3 lanes, 35 miles an hour, and you can see a rating of 2.4. So you can fairly easily use these tables with just a few basic data variables for an intersection to get a rating variable from 1 to 6. So you can see here, you also have a spreadsheet calculator available. You can either use a spreadsheet or you can use the series of tables. So you can see here is an example of, you might go out to a site, enter the basic information. This site is a 4-lane signalized intersection, 42 mile an hour, 85th percentile speed, 22,000 vehicles on the main line, and it's in a residential area. And this came out with a intersection safety index of 2.7. You can also use the chart to come up with the same number. So basically it allows you to apply this, this method to hundreds of intersections throughout your city and then rate them from the highest numbers to the lowest numbers, and then go and take a further look at the ones that have the highest ratings, whether they had any crashes or not, and make use of this method in conjunction with your crash data, where you've identified high crash locations, and then use the two methods to then go out and investigate, see if there's problems, and then come up with feasible solutions. Here's kind of a link to the website to see this guide, user guide, and Davian, I'll ask Davian to add these links to the webinar link that you have on the website. Just a few other resources I'll make mention to you is we do have the website walkinginfo.org. It's got many sources of information. You can see the main feature that appeared during this issue, this screenshot, was the actual user guide on how to develop a pedestrian safety action plan, from which it does discuss things like the data collection analysis. You can see in the lower part of the screen, there's a whole section of the website that does cover some of the main components of collecting and analyzing data. On our website, walkinginfo.org, we have dozens and dozens of pedestrian plans and pedestrian safety action plans. We have several of those from around the country, from cities and states around the country. There's another resource we call it the FHWA Residence Guide, and it's really geared more for citizens, neighborhood groups. And it's kind of a user-friendly guide to allow you to identify problems and solutions. And Davian mentioned this briefly at the beginning of the webinar. There's a course that gets more into the design and traffic control features of a roadway. We call it Designing for Pedestrian Safety Workshop. And so essentially, the learning objectives of this session was to allow you to integrate some of the data collection and analysis components of your pedestrian safety plan. This is going to help lead to the appropriate countermeasures. And some of those sessions on countermeasures will be coming up in the next few weeks. So anyway, that's sort of an overview of the presentation. And Davian, I'll try to answer any questions now that we have. So I'll turn it over to you.
Thank you, Charlie. Now we have some time for questions. Please enter your questions into the box on your screen. Again, if we run out of time for your question, we'll attempt to answer it and get to you after the program. Okay, Charlie, looks like our first question asks, are there studies showing the safety of complete streets for peds, bikes, and autos versus auto-oriented streets when they have the same AADT?
Okay. Okay, now let's see. So they're asking if what the studies show about complete streets?
Yes.
Okay. Essentially, I made some mention of some of the these issues earlier, but what we think about when we talk about complete streets, again, is providing safe facilities for all the different road users, kind of a balance the needs of all road users. We're talking about sidewalks, walkways, bike lanes, well-designed streets for cars, buses, trucks, and the answer is yes. That from the research that I've been involved with and others have been involved with, that when we look at roadways that have these conditions for bicyclists and pedestrians, in general, the answer is yes. If you do provide safer walkways and sidewalks, we mentioned that the research shows that you can reduce walking along roadway crashes by about 88% actually. If you have raised median islands, which is a really nice feature for motorists as well as pedestrians, you can reduce pedestrian crashes on multi-lane roads by about 35%. Plus, motor vehicle crash rates are much lower on divided roads than they are on undivided roads. If you have roadways with paved shoulders, bicycles have a place to ride and are less likely to be struck from behind by motorists. And I mentioned the left turn, having separate left turn phasing, how that can reduce left turn crashes to pedestrians and to motorists. So yes, having these features does lead to reduced crashes to all the different road users.
Okay, next. Thank you, Charlie. We'll move into the next question. Other than just using number of collisions at an intersection, do you use any other unit of measure to prioritize locations for improvements, such as collisions per number of pedestrians entering and crossing the intersection?
Yeah, that's a really good question. First of all, it would be really useful for safety analysis to have pedestrian exposure data, ideally even by age of pedestrian or some category classification of age. Unfortunately, we don't have nearly as much pedestrian exposure data as we would like. If you do have exposure data like some cities like Charlotte, North Carolina have, this can be a really valuable tool, and you can calculate pedestrian crash rates. I will also say, however, that I wouldn't just wait until you have pedestrian exposure data before you do your safety analysis. There's some real important things that you can do primarily with the crash data, and while it would be really useful and important to have exposure data, sometimes you can do short-term counts at some of your locations that have crash problems to better understand what's going on. And while you cannot calculate crash rates without exposure data, I still think there's some real value in looking at the number of pedestrian crashes, even if you don't have exposure. Because if you had two sites, for example, site A, let's say you had 10 pedestrian crashes over a 5-year period and fairly high pedestrian exposure. Site B, you only had 1 pedestrian crash and very low exposure. You may actually have a higher crash rate in site B with only 1 crash compared to site A that has 10 crashes. However, when you think about getting the most bang for the buck and how can you reduce the most pedestrian crashes, there's still something to be said for going to the site that has the 10 crashes, really identifying what's going on, and maybe your treatment could reduce 50%, 60, 70% of those crashes every year. That could ultimately result in a much greater reduction in crashes to your city than would be at the site that only has 1. So yes, collect exposure data, but don't let that keep you from doing an analysis if you don't have it.
Great. Thanks, Charlie. We'll move into the next question. Did I understand correctly that the PBCAT will assist with PED safety audit guidelines? Will this assist with identifying the need for possible mid-block crossings and PED islands using behavioral data? Are there other behavioral data collection studies that you would recommend?
Okay. Let let me clarify. PBCat doesn't make use of just behavioral data. Behavioral data is something that you'll want to do at the site that has pedestrian crash problems or other problems. PBCat is a tool that allows you to code all of your pedestrian crashes into certain categories, so you can group them into crash types. And then within the software, if you go and click on a given crash type at your location, it will then lead you to certain countermeasures that may be candidates for that. Now, so it's one of the pieces of information or one tool to allow you to better understand crash types, and then the tool also helps give you hints and guides on countermeasures that may be appropriate.
Great. Thanks, Charlie. We'll move into the next question. Do you have information and tools for evaluating pedestrian safety interventions?
Tools for evaluating safety interventions. I assume what they mean by that question is, is there a guidebook that says, here is how we should go on a step-by-step basis to evaluate interventions. There's not one particular guide that I can point you to. Part of it depends on, how rigorous, that you want to do the analysis. Do you want to do a well-designed statistical analysis of your countermeasure? Oftentimes that process, that evaluation process, has to be sort of selected based on the problem that you have, the number of sites that you have, and the resources that you have. In other words, the Federal Highway Administration and National Highway Traffic Safety Administration have programs where they fund national research, so that you could, for example, might have a study to evaluate treatments at mid-block locations. So there'd have to be a large fund of money to allow you to test out, various treatments at enough sites to allow you to have statistical confidence in your results. And it may be a multi-year study and cost several $100,000. So, but that's one kind of study that would be done from a purely research standpoint to help us understand the effects of a different roadway treatment. There are some ways to do lower cost studies, or sort of intermittent studies, where, for example, if you install some signs or markings or devices with only a limited number of sites, you wouldn't necessarily have enough sites or enough crashes to do a crash-based study. But you could, in all likelihood, even at a few sites, be able to go and collect some behavioral data before and after. In other words, collect the percentage of motorists that yield to pedestrians after you've installed a certain treatment, or see if your treatment reduced vehicle speeds on that approach, or whether that treatment improved the behavior of pedestrians that may have been violating a signal. So, in other words, there's a whole variety of kinds of evaluations that you can do. I cannot point you to one special study or report that tells you how to conduct evaluation, not sort of a one report that says how to do all of that.
Thank you, Charlie. The next question asks, do you have statistics regarding safety benefits of countdown pad heads?
Yes. The one main study that I'm aware of was done in San Francisco a few years ago. And basically what the city did is they took almost all of their downtown signalized intersections and replaced the traditional walk-don't-walk signals with the countdown signals, which are now mandated for all new installations, for all new pedestrian heads in the U.S. as of January 2009. And what they found is they found that can reduce pedestrian crashes by up to about 25%, by simply converting from the traditional walk-don't-walk to the countdown signals.
Okay, thank you. The next question asks, on a DOT roadway, has there been criteria developed for lateral separation of the sidewalk to the curb depending on vehicular speed? I know more is better. However, in condemnation cases, how do you justify additional RW above minimums?
Okay, that's a real good question. Talking about how much right-of-way do you need to provide good lateral separation between your roadway and your sidewalk. And there's not one magic number. Oftentimes, certainly the more separation you get, the better. You want to give some distance between pedestrians and motorists. You ideally do not want to have your sidewalk adjacent to the travel lane. Many sidewalks have been installed that way just for cost reasons. It's cheaper to do so. Maybe in certain instances where you have no additional right-of-way and all you have is your 5 or 6 feet beyond your travel lane, then that's better than nothing. Having a sidewalk or paved shoulders there is better than not having one. But I really recommend a minimum of about 6 feet. And again, right-of-way is a key issue because oftentimes you can spend a lot of money buying additional right-of-way. In some cases it might be justified. In other cases you might be able to get away with only 3 or 4 feet. So it depends on the situation that you have and how much right-of-way you have and the cost for obtaining additional right-of-way.
Thanks, Charlie. We'll move into the next question. Can you provide more detail on crash reductions resulting from lane reductions? Examples given, how do context, conditions, geometrics affect the reduction achieved?
Okay, the lane reduction, I mean, the number I gave you before, the 29%, that's the number that I would say I have the most confidence in terms of converting a 4-lane or 5-lane roadway to a 3-lane or even a 2-lane road with turn pockets. But again, it's not, this 1% isn't going to apply exactly to every single road type situation. That there are conditions that are going to make that number vary from site to site. So, the research is somewhat limited in that area. We don't know everything that we'd like to know about crash effects. We call them crash modification factors. That's essentially the number or the percentage of crashes that you would expect after a given treatment. Just an example of that is if you had a countermeasure that would reduce 20% of your pedestrian crashes, the crash modification factor would be 0.8. In other words, 1 minus 0.2. But we really need to have more research to be able to say with any more certainty, how some of these other secondary factors might affect that crash modification factor.
Thank you, Charlie. Have you modeled these steps with any bicycle-related assessments? Are the steps different at all?
Okay, that's a good question. Of course, the webinar series we're talking about today is for pedestrian safety action plan. Some of the steps involved could certainly be paralleled for a bicycle safety action plan. However, some of the specific countermeasures or even some of the data collection might be quite different for bicyclists and pedestrians. Bicyclists are vehicles according to our Uniform Vehicle Code. And some of the countermeasures that we can implement for bicyclists may benefit pedestrians, but in some cases they may be not so beneficial to pedestrians. So there have been some discussions about developing similar guides and even training for bicycle safety plans. The state of Arizona, I believe, is now in the process of starting up the development of a bicycle safety action plan. And we've heard others talk about wanting to do that, but so far I haven't heard a specific plan to do that at the national level yet, although that might be something that happens in the next year or two.
For ped collisions, have you considered time of day and day of week analysis?
Yeah, really good question. That is something that is a very important factor to look at when you're looking at not only your crash data, but also figuring out a time to go out and a day to go out and review your what's going on there. And I mentioned that if you're having nighttime pedestrian crashes, go out at night to see what's going on. Or if it's a weekend crash problem, go out during the weekend. As close to the time of the crashes as you can. And sometimes you'll get complaints about that are time specific or day specific. That there may be problems occurring on weekdays after school at school sites, or at certain times or days at senior centers, or with pedestrians crossing in certain neighborhoods. So yes, be very aware of the time and days when crashes are happening, and that can also be much more useful to go out and observe during those times.
Thank you, Charlie. Can you talk about the best ways to collect the number of pedestrians using the roadway on a regular basis to provide a realistic percentage of crashes per daily ped count?
Number of crashes per daily ped count. Okay, there's several techniques involved with collecting pedestrian exposure data. Certainly there's the hand counters, like you would find in the Institute of Transportation Engineers Manual on Traffic Studies. And so people can just use counting boards, and of course that is labor intensive. Some cities, have done this. Washington D.C. has for years would collect 8 or 10 hour counts of pedestrians at many of their downtown intersections. There's newer technology nowadays that has been used and tested that can do automatic counts. Pedestrians or bicyclists, like on trails. There are other kinds of camera video systems that have been tested out for doing automatic counts. Some of these methods are making good progress in terms of their development. I think there's still some questions about the accuracy of some of the automated counting techniques, but they are being developed and their progress is being made so that hopefully in years to come that we'll be able to have systems that can collect large number of sites with pedestrian and bike exposure without having to send somebody out in the field the whole time to do counts. I'll also say that there's a study underway now by the National Cooperative Highway Research Program to try to explore different methods to estimate pedestrian and bike exposure based on planning variables that many states have. So there is work underway to make use of existing data like land use data and population density and other characteristics of our urban areas in order to estimate pedestrian flows for uses for different planning and safety analysis.
Thank you. We'll move into the next question. We often face the challenge of cost of infrastructure improvements and the question of will people, peds and bicyclists, actually use it? If so, how much will it improve physical activity levels? What's the best way to estimate future use if infrastructure is put into place?
Okay, that gets into the question of if you build it, will they come? Kind of like the field of dreams question. And there has been some limited amount of effort to try to look at that question, that if you build a new sidewalk, how many pedestrians will start using it? Or if you add something as simple as marked crosswalks, will that increase the number of people that cross there? Unfortunately, from what I've seen, there's not any really good models and estimates to allow us to make those projections. I will mention that one of the recommended research studies as part of the new Federal Highway Administration's Pedestrian Strategic Plan that we had a part in developing did have that exact topic as one of the recommended studies, to go out and try to do some exploration of looking at new pedestrian facilities before and after in terms of counting their activity, so that efforts could be made to try to develop some estimates or models to predict future use of a facility if it is constructed.
Great. Are there resources for countermeasures for human behavior issues and dealing with different demographics or pedestrian driver cultures?
Okay, the answer is yes. There have been a couple studies I'm aware of that have been sponsored primarily by the National Highway Traffic Safety Administration. I think some efforts by the Federal Highway Administration to look at problems involving pedestrians, like with Native American populations, with Hispanic populations, two that I'm aware of. What we can do, Davian, is we'll try to list some of these resources, on our website to this particular webinar, because there's some information out there. When we dealt with the Miami-Dade Pedestrian Safe Demonstration Program, we were working with the local Metropolitan Planning Organization folks, and they actually developed a series of posters and educational messages in English, Spanish, and Haitian Creole because of the diverse populations that they have down there, that they knew that just having those messages in English would not be sufficient. So there's some resources we made use of there, and David, we can make a link to the Miami-Dade report and some of the educational messages that were used for the different populations.
Okay, that sounds good. And as Charlie stated, what we'll do is, along with the archive, we will place a list of the links that we've referenced in this webinar, along with a transcript of the presentation. We'll get into the next question. Raised medians are challenged by businesses concerned about limited access for their customers, with resulting decline in business profit. Furthermore, Almere is convinced that the middle lane provides emergency vehicle travel, and removing this middle lane is actually unsafe for the community. How can this be countered?
Okay, certainly there are legitimate concerns by some of the engineers and planners we've talked to that get resistance from local businesses and property owners. Whenever you talk about adding a raised median, that would limit access into their driveways, particularly from vehicles trying to make a left turn. And what some agencies are starting to do is to realize that, many times whenever you're going to make improvements to a roadway system, that you're going to get some resistance. The state of North Carolina, the DOT, a few years ago, started a policy to try to change their basic philosophy on building arterial streets, instead of a 5-lane road with that 2-way left turn lane, to more of a 2-lane in each direction with a wide median and left turn pockets. As I mentioned before, that cross-section really does have a beneficial safety effect to pedestrians. It really reduces motor vehicle crashes, and it's more of a complete street. And in spite of the fact that, yes, it's possible that fewer people can turn left directly into driveways, but some agencies have actually built in that left turn pocket so a vehicle can get into the left turn pocket. If they want to go into a fast food restaurant or a store, they can make a U-turn, and along that corridor, if there are traffic signals that set up artificial gaps in traffic, then it can be fairly straightforward to make that U-turn in spite of having a raised median there and still enter the driveways. Sometimes that can be used to accommodate the business owners. But many of the improvements that you do that can improve safety don't all necessarily get approval. Even adding sidewalks. We've seen property owners sometimes don't like sidewalks because they're afraid that will increase the walking along the street and may increase crime, which is shown to not really be the case. That usually that if there are more eyes on the street, there's some evidence that that's going to make it a lower crime area, and in addition to reducing the risk for pedestrian crashes. Also things like road diet improvements. Again, it's not uniformly applicable to all streets, but if the traffic volume is low enough, generally around 15 to 20,000 vehicles a day, 4-lane or even 5-lane roads might be converted to 3-lane roads. That provides improved safety to all the road users. It reduces speeds and makes a much more pleasant corridor, for the public in general.
All right. The next question asks, did you look at pedestrian sobriety and distraction factors such as cell phones and headsets? Same for drivers, sobriety and distraction.
Did we look at that in terms of what, our Miami-Dade study, or?
I believe so, yes.
Okay. What we ended up doing is we did observe hundreds of intersections and locations throughout the county, and that was certainly something that you observe and we noticed. Not all of that information is given in detail on the police crash reports, but where it was recorded, then certainly we would observe that. But as all of you know, I mean, cell phones and other distractions have become more and more a problem and more, in part of the discussion by safety officials. And so we know that that's an issue that contributes to sizable part of our pedestrian and other crashes. And not just drivers on cell phones, which is a big problem, but we've noticed more and more pedestrians on cell phones or other distractions. So it's something that we are trying to address. There's some of those things that can be you can try to address, but it's very difficult through traditional measures. And in fact, one of the studies that we've recommended through this pedestrian strategic plan is a study be done on driver and pedestrian distraction, like cell phone use and many other distractions as well. It's nothing new to have driver distractions, but now with the cell phones and text messaging, it's become even more of a problem and more of a problem that people are trying to address.
Thank you, Charlie. And we have one last question. What intervals are most helpful for post-project accident analysis, before and after comparison? Have you found that it is beneficial to do a third analysis in instances where drivers and pedestrians will have to change current behavior, such as a newly installed crosswalk or a roundabout?
Good question. When we conduct evaluations based on crashes, crash-based evaluations, clearly you want to have at least 1 year in your after period, preferably 2 or 3 years, and you want to have as many sites as you can to allow you to have a valid evaluation. If you only have 1 or 2 sites, it's almost impossible to do a crash-based evaluation, especially for pedestrian crashes. So in the study we did on marked versus unmarked crosswalks for Federal Highway a few years ago, we had 5 years of data, and we had 2,000 pedestrian crossings, 1,000 marked crosswalks, 1,000 unmarked. So we needed a sample size like that in order to have enough in our data set to be able to quantify some of the safety effects of some of these treatments. So it is, the more data you have, the better, and the more sites you have, the better in terms of quantifying crash effects. And David, if that's the last question, I would like to thank everyone for joining us today, and appreciate you taking the time. And if you have any questions at all, please email me or Davian, and we'll do everything we can to provide assistance.
Thank you, Charlie. Once again, a recording and transcript of today's program, as well as a view of the PDF slides, will be available in about a week at walkinginfo.org/webinars. Finally, I want to remind you that a brief survey will appear once the webinar has ended. Again, we very much appreciate you taking the time to complete it. I also do want to remind everyone about our next webinar, and the next webinar is on Wednesday, June 1st at 2 p.m. Eastern Time. This webinar is entitled Pedestrian Safety Education and will be presented by Nancy Pullen-Suford, Associate Director with the National Center for Safe Routes to School. Please visit www.walkinginfo.org/webinar to register for this webinar and future ones in the Pedestrian Safety Action Plan series. Thank you again to our speaker, Charles Zegeer, and thanks to all of you for attending today's PBIC and Federal Highway Administration Designing for Pedestrian Safety Action Plan webinar series. Thank you and have a great day.